we've got our median, we've got our quartile 1, quartile 3. That's great. Let's do a little aside here. Let's figure out what do they mean by decile, right? Well, decile is there's 10 deciles. All right, there's 10 deciles. You split the data into tenths. All right, we like tenths in mathematics. Our number system is based on tens, so it's only, comes from that fact that deciles are important. Deciles are important in your grade for this class because an A is the top decile. 10th decile is A, from 100 to, well, from 100 to 90, right? So if you're above the 9th decile, you get an A. If you get above the 8th decile, between the 8th and 9th deciles, you get a B. Between the 7th and 8th deciles, you get a C, right? So, we split our grades by deciles, so that might be an important thing to look at. In some graduate classes, they might look at, if you're in the top decile, you get an A. Well, they probably wouldn't do that. Maybe they might do quartile. For your top quartile, you get an A. Next quartile, you get a B. Next quartile, you get a C. I don't know. Some people use deciles to grade. All right. So before I lose my train of thought, deciles. Let's say we want to look at the 7th decile. All right. What is the 7th decile? So 7 times 10, 70. So we need to find the 70th percentile. So decile 7, 70th percentile. So we just use our same formula. P equals 70 divided by 100 times 46 plus 1. We'll have Excel compute what that is. I'm sure doing this by hand, good practice. You should do that if you want. So we want 32.9 position, so between 32 and 33. Now again, both these 85. We're not having a lot of luck with practicing with practicing figuring out what is 0.9 between these two things. But again, you do it in the same way we did the first quartile if the numbers were different. But since they're not, the 7th decile is, what did I have? 32 and 33, 85. All right. So you can do the same thing with the third decile. That'd be 30 divided by 100 times 46 plus 1. Okay. The 5th decile is the same as the median. Okay. So that's decile. Know what a decile is. And again, this is all talking about the position, the relative position of our data points, right? Okay, and then one more thing before we get to interquartile range, finding outliers. Let's look at a percentile. So you might have someone say, okay, what's the 66.7 percentile, right? What that's telling you is it's above 2/3 of the data, it's below 1/3 of the data. So that's a regular split, right? We split it in half with median, split it in fourths with quartiles. Why don't we split into thirds? All right, so the 66.7th percentile. Okay. So we just do this the same way. We put in the percentile, 66.7, divide by 100 times 46 plus 1. And we let Excel compute it. I did something funky there. Okay, let Excel compute it. 46 plus 1. Alright, so it's going to be the 31st, between the 31st and 32nd position, and it's going to be 0.349 of the way to the 32nd position. Now let's see if we got lucky. We did not get lucky, or we did, so I can show you what's going on. The numbers are different here, so we're going from 84 to 85. So we use the same kind of idea that we use with the quartiles, right? We go between the 31st and 32nd position. That means we're starting at 84, and we're going 0.349 of the way to 85. All right, so we have starting at 84, and we're going 349 of the way to 85. So we take the difference between 85 and 84. All right, and we'll have Excel compute that. Did that silly thing again. Okay, and I forgot to put a multiplication sign. That's fine. Excel's smart. Correct me. So the 66.7 percentile is 84.349. All right. So this hasn't been, I hope it hasn't been too difficult. It's just using this formula. So hopefully on tests now, or sorry, quizzes, the quiz, you should be able to use the Excel file to do all this. Now let's find the interquartile range. I'm just going to move this so it's not a distraction. Alright, and I'll move this over here so it's front and center. Okay, so the interquartile range range, or IQR, is just the difference between Q3 and Q1. As defined as the difference between Q3 and Q1. Okay. So in this case, we just take Q3, so 87, and subtract Q1, 70.75, and we get 16.25 is the IQR. Now, if you remember our box plots, some people call them box and whisker plots, right? The interquartile range is going to be boxed in. And this kind of helps us see how much of the data is in the middle there. What does the distribution look like? And we'll go more over what distributions look like later, but is there a lot of data close together in the middle, or is it kind of spread out further? Is there a uniform distribution or a normal distribution? We'll get to that. We'll get to what that means. But for now, just remember it's the third quartile minus the first quartile. And so 16.25. So what else can we do with the IQR? We can also find if there's any outliers. So we're going to define an outlier, and you probably already know this. So an outlier is more than 1.5 IQRs from Q1 or Q3. So an outlier is something that doesn't seem like it belongs within a set. Okay? So my next example is going to be with LeBron James, great basketball player. If he has a really bad game, you might call it an outlier. Say if he scores, say if he scores 8 points in a game, you might call that an outlier because it's so far removed from what his average is. And that can be the same thing with other data. You might look at stock returns. Okay, stock returns. Let's say that the Dow gains 5% in one day. That's an outlier. Okay, usually they'll gain or lose between 1 and 2%. So gaining 5%, that's going to be, a special day. It's going to be something that doesn't happen often, something that's very rare. So outliers generally rare, far away from the mean, and sometimes we kind of ignore them because again, they're very rare. We don't ignore them, but we make sure that people know that this is an outlier. Which is why you'll see on the box and whisker plots, or the box plots, that they're kind of stars outside of the range that we normally use. Okay, so more than 1.5 IQRs from Q1 or Q3. So what should we do here? We just find out what 1.5 IQR is. So 1.5 times IQR, and that's going to be 1.5 times 16.25 our IQR. So 24.375. So let's see if there's any outliers. We go 24.375 above Q3, so Q3 plus 1.5 IQR equals Q3, equals Q3 is 87, right? Plus 87 plus 1.5 times 24.375. We'll have Excel do this for us. And we get 123.5625. Now, that is wrong because I put in 24.375, which is 1.5 times the IQR. IQR is only 16.25, right? And change this to 16.25. Alright, so 111.375. So, is there any data that we get above 111? No, because these are test grades. Highest is 100. So there are no outliers that are above Q3. How about below Q1? So below Q1. Q1 minus. We got to do minus here because it's below Q1. 1.5 times IQR. Q1 was 70.75 minus 1.5 times IQR 16.25. Oh, we let Excel compute that. We get 46.375. That's right. So do we have anything at 46.375 or below? No. Right? Because the worst test was a 50. So there's no outliers in our data set. No outliers. Alright, so that's basically good practice there. I'm going to go over one more example. That'll be with LeBron James.